Hello everyone and welcome to Java Basics. Last time we created a simple database repository, but entries in the database assume we have a user ID, and we also need to write to the database. Today we will add a user ID to the single page application and connect all of that to the database. This will take us through the full stack, which means from the front end to the back end and the database. We will integrate these changes so every operation we perform will be written to the database correctly. The code for this video is available here. It's in the description too. Don't forget to start and follow me on GitHub while you're there, and here too while you're at it. We heard the word cookies before, and I discussed them briefly in a previous video, but I didn't really explain what they are or how they work. We know the name for them thanks to all the website prompts and asking us about them. But what are they? Let's start by explaining the situation before we had cookies. I could connect to a website, but say I said something in the website and wanted it to keep it. I had to tell it everything. So we can pass parameters when making an HTTP request, and that way the website knows to return the right thing. The problem is that if I bookmark the site or just find it again through a search engine, these parameters won't be there. This will all be lost. We need some way to remember things about it. So we can keep the script. When we ask the website to remember something, it returns a cookie and asks the browser to remember that for us. After that point, every request we make to the server will include the cookie as a parameter. JavaScript can also set cookies for us, so it doesn't have to return from HTTP. The point is that once a cookie is set, even if we have multiple tabs pointing at the website, they will all send the cookie to that website. This is convenient for tracking, but not just for malicious purposes. This is how logging into a website works. Without cookies, we would constantly need to enter our credentials. They are very convenient. They also give us control as users. We can see them in the browser which websites is storing information on our browser. We want to identify a particular Wordle player and keep track of his games. For that, he needs an ID. In this case, we don't care about his name or anything much. We just don't want him to be mixed up with someone else. A common standard in programming is the Universal Unique ID, which is a hexadecimal string representing a unique value. A UUID is created by using a combination of random numbers and the current time. So the chances of two UUIDs being the same are very low, almost impossible. This makes UUID very useful for things like creating unique user IDs or tracking individual items in a database. We will create a UUID to represent each user and store that UUID in a cookie, which will then be sent to the server. We have two front ends. We will use cookies for both. The single page application will work very differently to the MVC version. I will teach both since both approaches are interesting. Let's jump right into the SPA code and see how we can set a cookie for the user ID. We will start with something different. I'm pasting this line into the HTML file for the single page application. There are several interesting things about this line. I'm including another script tag above our existing script tag. That means the browser will run it first. This is a script that adds a function that can generate a UUID for us. Now that we included, our script can invoke that function and generate a UUID, and we don't have to write that code. This is something we do frequently in JavaScript. It lets us build sophisticated applications based on work by other people. Let's go to the script code and see how we can use it there. We create a new function to get a cookie by its name. Cookies are stored in the document and are separated with a semicolon. We use the split method to break the cookies into an array of strings containing the individual cookies. Notice we add the equals character to the cookie name. That's because the names and the values are stored like this. We want to find the cookies with the equal sign. This is important because if someone searches for the cookie named cookie, it will find cookie 1. The equal sign indicates that this is the full string. We loop over all the cookies and get the current cookie value. The trim method removes the extra white space in the edges of the string. So if there's an errant spaced character in the start or the end of the string, it will remove that. This is generally a good thing to do since space character is invisible and it is there. And if it's there, it's a bug that is very hard to spot. If the current string we're iterating over starts with the cookie using then a cookie string, then we use the substring method to return the value, which is right to the right side of the string. To understand what we're doing here, let's go back to the example from before. Let's say I want the value of cookie 2. In that case, cookie name would equal cookie2 with the equals sign in the end. The cookie array will include all the values without the semicolon. Cookie1 equals x, cookie2 equals y, and cookie3 equals z. As we loop, the first cookie doesn't start with cookie2 equals, but the second one does. The substring method will cut out the words cookie2 and equals and leave only the letter y. And the method will return that. If nothing is found, an empty string is returned. The method creates a user ID cookie if one doesn't exist. To determine if it exists, we first need to get the cookie. This method is a bit unexpected. This code is a bit unexpected. The exclamation mark means not in Java and JavaScript. We saw this used before, but not like this. In Java, this code is illegal. But in JavaScript, you can use the if statement on elements that aren't Boolean statements. If a pointer is null, a string is empty, or a number is 0, it will be the same as false. By using not on a variable that represents a string, we are essentially asking if there's a string here. The if will occur if the string is null or empty, which is the case when there is no cookie. We now invoke the UUID function from the script we included earlier. This will return a unique string that we will see later. Now we need to save that unique user ID into a cookie. The cookie has an expiration date. I can set the cookie to expire in 10 years by creating a date object and giving it a time in the future. This is time in milliseconds from epoch, which is midnight, January 1st, 1970. The way we set the date is by getting the current time and adding to it 10 years, which is 3,650 days, ignoring leap years, then multiplying that by 24 hours a day by 60 minutes per hour, then by 60 seconds per minute and 1000 milliseconds. We then define the expires value when setting the cookie. It needs to use the UTC date format, which is a pain to write manually. But thankfully, the date class can do that for us perfectly with the toUTC string method. We can now create the cookie string. Remember that string with the dollar and curly braces represents variable values. We give the user ID cookie name, which is user ID, then the value of the user ID variable. The expire string we just created, so far, so good. Path indicates the path in the website to which the cookie applies. You can restrict a cookie to a specific path if necessary. For now, we will leave it as such. There are many things we can further define with cookies, but for this use case, this is enough. Finally, we create the user ID and save the value. We don't really need the value here at the moment. It's mostly for the server. Still, it might be useful in the future, so let's keep it. Now, let's do the same thing for the String MVC application. The code there is similar yet different. On the server side, we can grab a cookie by declaring the cookie value annotation and a properly named variable. String injects the cookie into the variable for us if it exists. But unlike the single page application where the cookie is created on the client side, here we need to create the cookie on our own if it doesn't exist. Setting the cookie value to the variable will have no effect, as Spring won't know that we did that. We need to write code that adds a new cookie and returns it in the response to the HTTP request. Java has a standard API called the Servlet API. Spring mostly hides it from us, but if we need it, we can access some of its features. In this case, we can ask Spring to deliver the HTTP servlet response, which is part of that API. By just adding it to the method parameters, Spring understands that we need what we need and will give us access to that object. With it, we can set cookies into the response. We add this to both methods, as this might happen in both cases. The code to set a cookie is common to both guess and submit guess. As such, we will write it in a common method so both can use it. The method will return the user ID if a new one is created. If a user ID is null, it means we need to generate a UUID. Java has a much larger set of APIs and UUID support is built into it. We can generate the UUID using the UUID class. Adding the cookie itself is a matter of creating a new cookie object. We can set the max age to 10 years, just like we did in the JavaScript code, and then set the cookie to the response object. This will send it back to the client side. We return either the newly generated user ID or the existing user ID. We invoke the init method with the cookie and response, but assign the result to the user ID. This means the user is properly initialized or will keep its existing value. We can now copy the code to the other method, and with that, the cookie is set. Moving down, we can add the user ID to the show attempts method. So we will store the user ID when calculating the result. We can set it here to the calculate result method. This will show an error, so we need to fix that method. But first, we need to fix the two calls to show attempts in this class, so they both pass the user ID to the method. In the service class, we add the required args constructor to inject beans into the class. We then add the database repository, which we will use to save the requests from the user. In the calculate result method, we add the insert call that we implemented the last time around. This seems simple enough, but notice that we have a problem. We don't know the number of attempts made by the user. We could store this in the client side or pass it from there, but this would mean passing an additional variable. Also, the client might change the number of attempts. Maybe there's a better way. Up until now, we showed a relatively simple select statement to query the database. But databases are far more sophisticated. With a select count statement, we can count the number of rows in the given table. This returns an integer number representing the number of rows, but it goes much further than that. Let's go over the elements in the statement. We select one column and add it to the count. Here we define the table name in which we want the count to occur. The where clause lets us define a condition to the query. Since multiple users will submit guesses in a given day, we only want the answers applicable to the current user ID. We can restrict the query to only count the rows where the user ID matches. The AND keyword lets us put another condition in the same entry. There is also an OR condition that we can use to pick between one of two separate conditions. In this case, both conditions must be true for the select statement. We want the word to be the same, otherwise this will count words from different days. We can similarly add this to the select statement, where we can return only the guesses made by the current user. We can also add other useful properties. In this case, we can order the results based on the attempt number, which makes sense as we might want to display the results in this order. SQL is a very powerful language, and I'm barely scratching the surface here. How we can update the select all method and accept the user ID here too. We now need to pass that ID to the query, and we will only get the results of this particular user. If attempt is 0, it means we will need to calculate the number of attempts. Up until now, I didn't use the AND statement when defining if conditions in Java. This is an AND in Java or JavaScript. It combines two conditions together, and both must occur for it to succeed. Let's dig deeper. When both conditions are true, we will get true. That's pretty obvious. If one condition is false, we will get false. But this is where things get interesting. Let's say we have a condition like that. There are three possible situations. Method A is true and method B is true, in which case this will be true. If method A is true and method B is false, this will be false. But here is the interesting part. If method A returns false, method B won't be invoked. If a false occurred, it is obvious the entire condition is false. That means that if there is no need to run method B to determine the result, this means that if method B changes something, those changes won't happen. This is subtle but important. We also have the OR symbol, which is represented by two pipe characters in Java and JavaScript. When both sides are true, the result is obvious. But unlike AND, this will be true since only one condition needs to match. This is where things get tricky. If method A is true, then method B won't be executed. The exact opposite of the AND operation, because it's enough for method A to be true. However, if method A is false, then method B will be executed again. The exact opposite. But this gets a bit more complex. This code isn't obvious. A person new to programming might read this in the order it is written, but this works more like math, where multiplication precedes addition. The AND operation precedes the OR operation. So this says something closer to B and C, or A or D. So if only B will be true, the results would be false, since the AND statement will return false and all the statements will be false. We can use brackets just like we do in math to shift the order of operations. The content of the brackets is processed first, and that way the OR statement will occur instead of the AND. In this case, the result would still be false though, since the right-hand side statement will end up as false. Going back to the code, we can issue the count query and save the result to the attempt variable. We can then pass this variable instead of the value from the record, and it should all work well. Notice that IntelliJ highlights the query in yellow. That means that the method I invoked here returns an object, which can be null. I converted this object to an integer without checking if it is null first. This can throw a null pointer exception, which would be a bug. In this case, it's less likely, so I left that in place. But you should keep your eye open for things like that. One of the great things in Java is how the IDE tries to help you find these sorts of problems before they occur. Going into the web service, which serves the single page application, we notice that it doesn't collect the cookie. I can paste the code for the cookie here and pass the user ID on to the Wordle service that we updated earlier. Since we changed the select code, we need to also fix the test, which we do by passing the user string to the select method. But we also need to test the new functionality we just added. We'll test this by adding two users. There are better ways to do this, but for simplicity's sake, I'll just add two users with 0 as the attempt value. This will force numbering based on the new count code. I can now select the elements and then compare them to the result. Notice that the second entry in the result has the correct attempt value as the last argument, since the insert API should update that value. With that, we can run the tests, and they indeed pass just as expected, which means we save the right stuff to the database. In a real-world application, I would also have tests that cover the web service layer and the front end. But for now, let's try testing those in the browser and the debugger. When I enter a word into the web UI, this hits a breakpoint I set in the server. When we enter a word into the web UI, this hits the breakpoint I set in the server. Here we can see the value for the user ID is a UUID generated on the client. I can repeat that and see that the cookie indeed remains and the user ID is correct. This was a long video, but I hope you get a sense of the power involved in databases and user identity. I didn't get a chance to talk about object-oriented much. I hope to cover that and JPA in the next video, as we're nearing the end of the series. If you have any questions, please use the comment section. Thank you.